Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today, we are going to discuss the topic on the double integral in polar coordinates. That means the title is the double integral in polar coordinates. In last class, we discussed whenever the integrations are under the double integrations, the limits are the constants and again the variables, and sometimes the limits are not given. How to find the solutions we discuss clearly. That means the limits are in the constants means a comma b comma c comma d, and again the variables is nothing but whenever the limits are like in terms of x, y, or y, and again x, that is with respect to dx and dy, that is also completed. And moreover the third method, that is limits are not given, how to find the limits, and again after that finding the limits, then how to find the solutions, that also clearly we discussed that previous sessions. And today whenever the limits are given the polar coordinates, first of all we need to understand what is the meaning of the polar coordinates, and again how to find the solutions. That means under the r comma theta is a polar coordinates generally. And before going to discuss that, we discuss how to directly the limits are given in terms of r comma theta, that with respect to dr and theta. That means, for example, the problem is that evaluate integration 0 to pi and a to 0 to a and r into dr d theta. That means here particularly the given limits are in terms of r comma theta. That means the dr into d theta. And in the dr into d theta is nothing but the limits are required with respect to like r limits and also the theta limits. As we know that r limits are like for here 0 comma a, because of here the constant values like that, and again the theta limits are nothing but as we know that like in terms of the pi values. Therefore while we are going to observing here the limits are that 0 comma pi is the consider, it is a theta is equal to 0 to pi, and again r limits are 0 to a. And again here first that 0 comma a, that means we need to do that integrating with respect to r value. While we are going to do that integrating with respect to r, it is a r square by 2. And again r square by 2, the limits are in between 0 to a and again into d theta. That means here upper limits are, you need to replace here r is equal to 0 to a and lower limit is 0. And after replacement of upper and lower, the value it will be that a square by 2 into d theta. And further we need to proceed that with respect to theta. And theta is nothing but here a square by 2 is a constant. We need to take out common outside, and after take out common a square by 2, and again integrating is a 1 with respect to d theta. That means that one integration is a, that is a theta. Therefore replacement of at t is equal to the limits are 0 to pi, and after replacement of the theta is equal to 0 to pi, the solution would be that is a pi into a square by 2 is a solutions. That means in this particularly this class, that limits are, that is with respect to r and also theta, the limits are in terms of like r is a constants and theta in terms of the pi value. And similarly, for example, here the problem is minus pi by 2 to pi by 2, and here other limits are 0 to 2 cos theta, and here r square into d theta dr, and here the limits are in terms of theta. In terms of theta is nothing but we need to assume that these are the particular limits are r is equal to, and if it is r is equal to 0 to 2 cos theta, and rest of the limits are the theta is equal to minus pi by 2 to pi by 2. That means we need to integrating first with respect to r. While we are going to integrating with respect to r, the theta is a constant, and again the r square integration is a r cube by, that is a 3 conditions. That integration of r cube by, that is a 3, it is a correct form, that is r cube by 3. The limits are 0 to cos theta d theta, And again, here in price of r is equal to, we need to replace cos theta. That is 2 cos theta and lower limit is 0. While we are going to replace the lower limit, that is the value is 0. And again, replacement of upper limit, that is a 2 cos theta, that is a whole cube by 3. Here 1 by 3 take out common. After take out common 1 by 3, that is 2 cos theta whole cube minus 0 because of upper limit and also that is a lower limit. And here 2 cube, that means 8. 8 by 3 take out common. The rest of the thing minus pi by 2 to pi by 2. The variable is here, that is a cos cube theta and again theta. And again, as we know that after take out common 8 by 3, here integration of minus pi by 2 to pi by 2. And again, it is a cos theta of whole cube into d theta. And as we know that one of the property, it is a cos theta is a function, is a even function. The limits are in between minus pi to pi like that. That is according to by the property. Here, that is 8 by 3 into 2 into multiply and 0 to pi by 2 and again cos cube theta into d theta. That is by the property of, that is a even function. We need to replace the negative to positive, that is a 2 into multiply, we get the solution. And again here, after that modification like this, it is a 2 into integration, that is a 0 to pi by 2 into cos cube theta into d theta is a value. And again here, that cos cube theta. Integration of cos cube is nothing but by using again the formulas that according to m is a even function or n is a even function based upon the property, we get clearly after that simplification 2 by 3 into 1, it is a solution. Therefore, finally, that is a 32 by, that is a 9 is the final solution. And meanwhile, in this problem, we need to apply that based upon the m is a even and odd, that based upon the properties, it is a 2 by 3 into 1 is the final solution. And again, for example, the problem is integration 0 to pi by 2, 0 to 1 minus sin theta, r square into cos theta dr d theta. And here also, the limits are in terms of theta, first one. And again, the rest of the values are 0 to pi by 2. And here we need to integrating with respect to dr d theta. That means one is with respect to the limits are r and other one is a theta. While we are going to observing here in this problem, the theta is nothing but this particular limits are assumed that r is equal to in terms of theta and rest of the limits are, we need to assume that is a theta is. By taking like this, here it is a integration 0 to pi by 2, that is a theta limits. And again, the first one, it is r, that is 0 to 1 minus sin theta, r square into cos theta, dr d theta. And here, the integration with respect to r first one, therefore, cos theta is a take out common. And again, after take out common cos theta, the integration of r square is equal to, that is r cube by, that is a 3 value. And again, that is a cos theta, that is r cube by 3. That limits are 0 to 1 minus sin theta and d theta. And further, we need to replace in branch of r is equal to upper limit is 1 minus sin theta and lower limit is 0. And based upon this one, it is integration 0 to pi by 2 cos theta 1 minus sin theta whole cube. Because of here, the lower limit is r is equal to 0. That second lower limit is totally the value is 0 into d theta. And based upon this one, again, while we are going to observing here, it is a cos theta and it is a minus sin theta. And it is not possible to find directly integration. Therefore, we need to take that, assume that sin theta is equal to t and again cos theta is equal to dt. Therefore, it is a integration in terms of the t changing by the substitution method. Therefore, 1 minus, that is a t whole cube. And here it is 1 minus t whole cube is nothing but 1 minus t whole power of 4 by 4. Otherwise, it is assumed that it is a formula based upon f of x is a like based upon whatever we know the intermediate formula, that is f of x whole power of n into f dash of x into dx is equal to f of x of whole power of n plus 1 by n plus 1. And in this, that f of x and f dash of x is clearly satisfied based upon the condition of it is a property. And here it is a cos theta 1 minus sin theta whole cube. And again here, again as we know that it is a we required it is by taking the 1 minus sin theta is equal to t, and again cos theta is equal to, that is a dt. Therefore, t cube, the integration of t cube is nothing but t power 4 by 4, and t is nothing but that is 1 minus sin theta. That means here we need to assume that 1 minus sin theta is equal to t, and again minus cos theta is equal to dt. Therefore, from the given, the term it is totally t dt. Therefore, the other term is a t and it is a dt. That therefore, integration of t into dt is nothing but that is a t cube, t square by 2. But here t cube is available. Therefore, that is a t power 4 by 4. The t is nothing but we assume that already 1 minus that is a sin theta of 1 power 4 by 4 is a value. And based upon this method, that is a substitution method, we need to assume here. And after that simplification, again we need to replace a t is equal to, that is theta is equal to 0, up lower limit, and upper limit is theta is equal to pi by 2. And based upon by replacement of all these values by using the upper and lower, the solutions it will be, that is a 1 by 12 is the final solution. That is our depend upon the simplification, we can obtain the solution. And similarly, for example, the problem is 0 to sin theta, and again 0 to pi r into dr d theta. And here also the limits are in terms of theta. That means we need to assume that particular these are the r, and again the theta is equal to 0 is the limits. And here also first we need to integrating with respect to r. Therefore, based upon the integration, that r is r square by 2. And again, here r square by 2, the limits are replaced like r is equal to 0 and upper limit is sin theta. And again, after replacement of that upper and lower, that is a r square by 2, that is a sin square theta by 2 is a value. That is a sin square theta by 2 because of the lower limit is a 0. And here also that sin theta whole square, that means based upon the sin cube or 1 minus cos 2 theta by 2 is the value. That means according to we know that cos 2 theta is equal to 1 plus sin 2 theta, 1 like 1 minus sin 2 theta, and based upon that you need to convert sin theta is equal to 1 minus cos 2 theta by 2. And again here it is a sin square theta, that is nothing but 1 minus cos 2 theta. That value only we need to replace here. And again here, again that 1 by 2 take out common 1 by 4, and in rest of the term is 1 minus cos 2 theta, and integration of 1 is theta, and cos 2 theta integration is that is sin 2 theta by 2 is the value. And again the lower limit is something 0 and the upper limit is pi. And while we are going to do that, after that replacement of a theta is equal, that is 0 to pi, we obtain that pi by 4. That means here simply that 1 by 4 take out common, it is a theta minus that is a sin 2 theta by 2, the limits are 0 to pi. And after replacement of here upper and lower, we obtain that pi by 4 is a final solution. And similarly, like other simple, that is a 0 to pi by 4 and 0 to 1, and again r into dr d theta. And here also the problem is like the limits are like 0 to 1. That means you need to assume that v1 r value, and because of the other limits are in terms of pi, therefore we need to assume that theta is equal to. And again here first with respect to r, and here also that r square by 2, and again the limits are 1 by 1 r square by 2, and again that integration, that upper limit is 1 and lower limit is 0. Therefore that is 1 minus 0, the numerator, the denominator is 2, therefore 1 by 2. And 1 by 2 we need to take out common outside, the rest of the thing is 1 into d theta. And again here 1 square is nothing but it is a 1 value. And again we need to integrating with respect to theta. Therefore integration, that 1 into theta is with respect to means that is a theta. And again 1 by 2 into that theta is nothing but replacement of upper limit and lower limit, the value is a pi by 4. Therefore the final solution it will be, that is a pi by 8 is a final solution. And similarly, like integration, the limits are 0 to pi by 2 and 0 to a into 1 plus sin theta r square into cos theta. And here also the limits are in terms of one is a theta and other one is a pi by 2. And integrating with respect to dr and d theta. That means the limits are one is a particularly for r and other one is a theta. And while we are going to observe here, the theta in terms of given, that means we need to assume that it is a r is equal to, and other one the theta limits, because of other one is r comma theta, one is r, means automatically the theta is equal to, that is 0 in terms of, that is a pi by 2. And again here also that solution is based upon that integration. First we need to do that, that is r limit, r integration. Therefore here cos theta is a constant, that is a take out common, and r square integration is r cube by 3. Therefore r cube by 3, the limits are in between 0 to a into 1 plus cos sin theta into cos theta. And again here also that the replacement of upper limit is a into 1 plus sin theta, and again whole cube by, that is the lower limit is 0, and again here 1 plus sin theta whole cube into cos theta. And similarly it is also based upon just now we discussed in the previous session, that is a previous class, like previous problem only. Here f of x and f dash of x based upon the formula by taking the substitution method. Here also we need to assume that 1 plus sin theta is equal to t. It is a consider, from here it is a t, and it is nothing but dt, and it is a t into dt, it is nothing but, that is a t square by 2, that is a t square by 2. That means based upon the t square is nothing but, it is already assumed that 1 plus sin theta, the t square is nothing but 1 plus sin theta whole square, and based upon such type of this condition, we obtain the solution is a value. That means it is a d into d theta, means that is a t cube into dt, and again t cube integration is a t power 4 by 4, and again here already assume that t is equal to 1 plus sin theta, and based upon this substitution method, we obtain that 1 plus sin theta whole power 4 by 4, the limits are 0 to pi by 2. And again after the simplification of this at theta is equal to, that is upper limit is pi by 4 and theta is equal to 0 to 0, the final solution it will be 5 by 4 into a cube is the value. And similarly like any problem, here also 0 to pi and 0 to a into 1 plus cos theta into r into d theta, and here also the limits are theta in terms of, therefore we need to assume that r, and again the rest of the limits are theta is equal to, and here also only one variable, that is r is there, that we need to integrating with respect to r. Therefore that is r square by 2, and again the limits are in between 0 to a plus 1 plus cos theta, and by replacement of upper limit it is like 1 plus a into 1 plus cos theta, that is a plus 1 plus cos theta whole square by 2, because of the lower limit is 0, and again here a square is a constant, you need to take out common outside, that is a square by 2. And again here as we know that 1 plus cos theta is nothing but 2 cos square theta by 2, based upon the formula, here cos power 4 into theta by 2 is a value, and again the integration with respect to 0 to pi, therefore here take out common, 2a square is already existed, and cos power 4 theta into t theta, therefore it is a cos power 5 by like 5, therefore by replacement of that according to substitution method, we obtain that 3a square pi by 4 is a value. Otherwise we need to use with the help of the, like m is even and n is even, m is odd, n is odd, m even and odd, based upon the formulas are also we obtain the solution is here 3 square pi into pi by 4 is the final solution. For example like 0 to a into 1 plus cos theta, and here also we need to assume and theta is equal to 0 to pi, and based upon here the integration r square is r cube by 3, and again the limits are in between 0 to a into 1 plus cos theta, and cos theta is a constant, we need to take out common outside, therefore it is r cube into by 3, and again a into 1 plus cos theta, and again here we a into 1 plus cos theta whole cube by 3, and again here also a cube by 3 is a take out common, and 1 plus cos theta whole cube into cos theta, here also by using the formula like according to by substitution method or any by expansion method, finally we obtain the solution is 5a cube into pi by 8 is the solution. And similarly like it is also one interesting problem, that 0 to pi by 2, that means these are the limits for particularly it is treated as, that is r, and again the theta is equal to 0 to infinity. But while we are observing in this problem particularly, it is e power exponential terms, it is e power minus r into r. First we need to integrating with respect to theta. And again here, sorry here that limits are theta is equal to 0 to pi by 2 and it is r is equal to 0. That means theta is equal to and again r. Because of the limits are in terms of pi by 2 means that we need to assume the theta, as we discussed in previous example. The limits are under like with respect to r comma theta in terms of pi by 2 is nothing but that is a theta, and again other value is a r value. Therefore 1 with respect to 1 is a theta means that is a theta. Therefore upper limit is t0 to pi by 2. Therefore pi by 2 is take out common. Integration r into d power minus r square into dr. And here also, while we are going to observing this one, we need to assume that either the r square or something r square by taking the t. And again you obtain that that is a 2 theta into d theta. Therefore it is based upon that clearly it is a e power minus r square into it is nothing but e power of t into that is a e power. If it is a consider minus r square is equal to t, then it is a minus 2r into dr is nothing but that is a dt is a value. Therefore e power t into that is a dt. Therefore integration of e power t into dt is nothing but e power t only. And again e power t into dt means, for example, it is a integration of 0 to infinity and e power of t into dt, and e power into t is nothing but e power t. The limits are 0 to infinity, and based upon this one it is clearly showing it is a by replacement of upper and lower limit, it is a solution. It will be pi by 4. Already be existed pi by 4, but it is a minus pi by 4 into that is 0 minus 1. Therefore it will be obtained that is a pi by 4 is a final solution. And again, similarly, when we are going to discuss the under the double integration, if the polar coordinates are also not given, then how to find the solutions? That means up to the is a previous example, it is the limits are given directly. Then how to find the solution? Then easy we completed. Now we are going to discuss if the polar coordinates are not given directly, then how to find the polar coordinates, and with the help of whatever it is a concept are there, then we need to find the solution. That means the double integration over the general region, that is under the polar coordinates method. That is the meaning of whenever the polar coordinates are not given directly the limits, they are giving such type of the equations, then how to find the equations, draw the diagram. And again after draw the diagram, we need to identify whatever the intersecting points, and based upon the points we need to find the solutions by using the r comma theta. And while we are going to discuss here under the polar coordinates, we need to discuss the basic concept what we discussed in the previous session. That means if the limits are not given variables like based upon the concept of the x comma y, and again that we need to discuss. That is the meaning of here in Cartesian coordinates we are having the x-axis and y-axis in the two dimensions. That means that is under the region of the two. And here for example x and also it is a y-axis, and based upon this one we know that similarly what is under the polar coordinates. And under the polar coordinates are also that parallel to like x is nothing but it is a r-axis, and again y is nothing but it is a like a theta. Y is nothing but it is a theta axis. That means it is a r is nothing but here the theta is a y. That means indirectly it is a angle between the conditions. And based upon such type of these are the simple knowledge while we are going to remember, then easy to find the solutions under the polar coordinates. That means under the x is a like x-axis and y is y, but here that r comma theta, that r is nothing but on the like x-axis, and theta is nothing but that is the angle between the r comma this is the conditions. And based upon that we need to understand. And before going to that also, we need to aware of that strip parallel to x-axis and strip parallel to y-axis. What we discussed in the previous session, just we need to recall here. For example, under the x-axis and y-axis, as we know that, for example, by taking the two cars, these are the, if you consider this is the parallel to x-axis, and with the help of this diagram, it clearly shown what it is here. It is x is the with respect to x, and again the x limits are that is the inner strip it is a p, and again the outer strip it is a q is a condition. And again the other thing, the limits are y comma like lower limit y, and also the upper limit is also y. And here the lower limit y is the point is particularly that is a c, and again the upper limit is particularly the point is a d is a condition. And this is the parallel to x-axis. And we discussed previous session based upon such type of this parallel to x-axis, then how to find the limits, how to find the solution. And similarly, we need to understand what is a parallel to y-axis. And parallel to y-axis also based upon such type of, this is the example, like the diagram. And again, here it is a parallel to y-axis, nothing but in the showing that is symmetrically about the, like according to parallel to y-axis. That means that is the meaning of here, it is under the parallel to y-axis, first with respect to y and again after with respect to x. And under here that integrating with respect to y is nothing but it is a y inner part is clearly showing that is a p where it is located here in the diagram. And again that q upper limit is that is according to that is a condition. That means that p is equal to this is the value and again q is nothing but it is a condition. And again the rest of the values, that means x limits, the x limits are clearly showing it is x is equal to it is a and again x is equal to that upper limit it is a b is a condition. These condition, these procedure just we need to remember while we are going to discuss under the polar coordinates. And again these are the under the parallel to x-axis and y-axis. And based upon this together, we need to discuss under the polar coordinates. Here, the procedure to find the double integral over the region under the polar coordinates. For example, if you want to find the value of given double integral over the general region in the polar coordinates, we will follow the following steps. What are the following steps? We need to discuss here, concentrate properly, then easy to understand. It is first of all, we need to draw all the curves and identify the required region. That means from the given any curves in the under the polar coordinates, we need to sketch the diagram that with the help of the given that is a required region. And next one, take the strip from the origin within the region. That means after draw the diagram of the above first step, we need to find out the strip where it is a origin started. That means with the given the particular region, and after that, if required, then divide the region into two parts. That means according to in the previous session like that, sometimes it is only bounded of single region and sometimes it is bounded the two regions. That is the meaning of according to dividing into like dividing the two parts, and based upon such type problems are also we discuss. And here also if the required, then divide the region into two parts. And again similarly find the limits of that is the inner integral the strip that is r1 and also r2. That means after draw the diagram, we need to understand properly what is the region bounded by the inner part and again the outer part. And again similarly we need to find that angle between the inner part to outer part, that is the meaning of theta 1 and also theta 2. And here after that finding the limits, again we need to calculate the examples as examples of the double integral. And this is the steps we need to follow whenever the limits are given under the double integration that polar coordinates. That is, this is the concept only. Here, for example, strip are according to under the double integration r comma theta. While we remember according to the previous that is a working rule, and here also just we need to understand here. For example, the diagram should be according to under the r comma theta. For example, it is a bounded region. Any two given the curves are satisfied like according to this is the diagram for example. And again here the bounded region is like this. That means none other than it is a not bounded the region. It is bounded region is nothing but from the given two curves when you are observing like it is a closed area, that is a bounded region. And based upon this bounded region, we need to follow the steps like finding the r comma theta, that is inner part of the r and again outer part of the r. And again similarly what is inner part of the theta, the outer part of the theta. And here it is clearly the bounded region is it is theta is nothing but the blue color. And again based upon this one it is a r. That r is nothing but it is a region. That region is bounded where it is that, not it is the angle. That r is the region, that is where it is the inner part of the region, what is the outer part of the region. That means while we are going to observing, it is r is nothing but it is a from here and it is a from here. That is a region, that inner strip is according to based upon the inner part, the outer part is according to this is the condition. That means we need to identify the inner strip is R is equal to, that is a first curve, and again R2 is a second curve. That is the meaning of the outer curve of the second part. And again, next we need to identify the theta limits. The theta is limits is nothing but in between R1 comma R2, where it is a angle between. That inner angle is nothing but, while we are going to observing here, the inner angle is a, here clearly the first one, and again that is a theta is equal to theta 1. The outer angle is nothing but in between, the theta is equal to theta 2. And this is the meaning of clearly we need to identify from the given any cause. First we need to draw the diagram, and after draw the diagram we need to observe properly what is the region the inner strip to outer strip, and what about the inner angle to, that is the outer angle, that is R1 and also R2, and again the theta 1 to theta 2. And based upon this concept, we need to find the solutions. And before going to discuss, we need to remember some of the few curves under the polar coordinates. If we remember these are the some few curves, then easy to solve any problem. Like few important curves under the polar coordinates, like examples are circle, and again the cardioid, and again lemniscate. And what is the meaning of this one, what type of the diagram, and again what is the angle, what is the like a center, and also the radius. And based upon such type of this knowledge, if you remember, then easy to calculate and easy to understand. And circle, for example, the problem is a equation of the circle, and under the polar coordinates what is a circle equation. That means in generally, for example, it is a r is equal to a, for example, and r is equal to a is nothing but here radius is a, and the circle is a center is a, that is 0 comma 0. And based upon this a is the radius and 0 comma 0, if we understand, remember in our mind the structure of the under the polar coordinates, that is like two dimensions, that is clearly r is equal to a is the radius here from radius, and again the center is nothing but it is the origin, the center, therefore it is a circle, that is with the help of that r is equal to a. Similarly, equation of the circle in other one, a into cos theta. And this is also, if it is a considered r is equal to a is a circle equation, and here the radius is a by 2, and center is a by 2 comma 0. That means here radius with the help of the a by 2, the center x coordinate on the a by 2, the y coordinate on the 0. And if we draw the diagram with the help of that r is equal to a into cos theta, the diagram should be clearly like according to, here it is a by 2. Because of here it is a is a radius, it is from here to here, it is a by 2 is a center. The x coordinate is on the a by 2 is the value. Because of it is from here to here a, that means here a by 2 to up to it is a is the value. That means the center is a by 2 comma 0 is the value, because of a is a 0. And similarly, for example, the problem is that r is equal to a sin theta. That a sin theta is nothing but here also the radius is a by 2, the center is 0 comma a by 2. While we recall or remember such type of, this is also like a example that circle, the diagram should be clearly symmetrically about like according to the above portion of the x-axis like r-axis. Here also the radius is from here, that is a by 2, and again it is a is the value. That means here also that a by 2 is like y-axis on the intersecting, and 0 is a center. It is also clearly the diagram should be like this. For example, the cardioid. The cardioid is nothing but here, while we are going to observing, the cardioid is according to like 1 plus cos theta. The diagram should be like this. That is clearly that parallel symmetrically about the x-axis. And here r is equal to a into 1 minus cos theta. The diagram should be symmetrically about the opposite of the x-axis. Like clearly. Okay, that means a is equal to r is equal to a into 1 plus cos theta is the right side, and again 1 minus cos theta is equal to left side. And similarly, some other cardioids like r is equal to a into 1 plus sin theta. It is also like according to while we are going to draw the diagram, we obtain. Yeah, that means above the x-axis and parallel to like y-axis, like symmetrical above. And again, similarly, r is equal to a into 1 minus sine theta. That means the reverse of the a into 1 plus sine theta. This is the below side of the x-axis. Like, yeah. And these are the some like circles and coordinates. And again, similarly, for example, the lemniscates. What is the meaning of the lemniscate? And again, what type of the diagram should be obtained? That is a lemniscates. For example, equation r square is equal to a square into 1 cos 2 theta. Here, like this type of the structure is called as a lemniscate. And similarly, it is a r square is equal to a square into sine 2 theta. Like with the help of this cos square theta, these are the angles intersecting pi by 4 and 3 by 4 clearly, as we know that. Yeah. And again, similarly, r square is equal to a square into 1 sine square theta is nothing but like above the parallel to like x and also that y. For example, based upon by remembering all the previous like circle and cardioid and lemniscate, while we are going to do that problem, we discuss find the value of the double integration r cube into sine 2 theta and dr d theta. Here, over the area bounded in the first quadrant between the circles r is equal to and r is equal to 4. While we are going to observing here, the problem is not given the directly the limits. Here given that equation format under the polar coordinates. That means whatever we discuss here, with the help of the diagram, based upon the diagram, we need to draw the diagram. That means here already we discussed that here r is equal limits are 2 and 4. That means here 2 is nothing but is a constant. As we know that given the diagram, it is a related r is equal to a, and r is equal to 4 is also based upon r is equal to a. And whatever we understand, that is the diagram should be r is equal to a. And with the help of that, you need to sketch the diagram that is based upon according to the condition procedure. Draw all the curves and identify the required region and take the step from the origin with the region. And if required, then divide in the region into two parts. Find the limits are r1 and r2 and theta 1 and theta 2 and calculate with the help of the given problem. This is the based upon the procedure of the under the double integration r comma theta, and again based upon that understanding level of what we discussed, like given the diagram r is equal to a, that is a circle equation, and based upon that r is equal to a, first we need to draw the dark circle. And here clearly it is a circle is r is equal to a. As we know that what type of that r is equal to a, that means passing through the origin. And here that passing through the origin, but here also the passing through the origin, the radius is a. Therefore, with the help of that r is equal to 2, the circle is passing through the origin. And again, similarly, we need to draw the diagram. What is the r is equal to 4? That means here the radius is a 4. But in the first one, r is equal to 2, this is the circle. And now, r is equal to 4 is one other circle. With the help of the radius is 4. Therefore, the circle is with the help of the 4, this is the circle. While we are going to observing in this, particularly like here, that circle is first r is equal to is the red color and 4 is circle is the blue color. While we are going to observing this one, we need to understand properly what is where it is bounded the region. And here, actually the bounded region is in between r is equal to 2 is the inner and r is equal to 4 is the outer. Therefore, while we are going to observing, this is the totally bounded region. And clearly by observing this one, it is totally bounded region. And in this bounded region, while we are going to observing here, it is a problem is given that is the first quadrant only occupied. Under the first quadrant, coefficient like quadrant is occupied means we need to consider only here, this is the part. That means it is a second quadrant and fourth quadrant, it is a not covered. That means with the help of that r is equal to 2 and r is equal to 4 is the diagram is over. And where it is a bounded region is also completed. And next, where it is a particularly in this diagram, where it is a occupied region, that means first quadrant. That first quadrant is nothing but the meaning of here according to we graphed. That means this is the meaning of it is a first quadrant. It is a bounded region. And in this bounded region, we need to identify what about that limits are inner strip to outer, and theta is also what is the inner angle and again outer angle. Here, that while we are going to observing here, the region is r is equal to 2. That means inner part is the first one inner part is here. It is a red color. That means r is equal to 2. And again, the outer part is r is equal to 4. That means here the lower limit is r is equal to 2 and r is equal to upper limit is 4. And again here that is a region is required. Therefore, r is equal to 2 is a lower part, and again the theta r is equal to 4 is a outer part, and rest of the theta limits. The theta is a we need to understand properly in this total bounded region where it is occupied. That is a theta. The theta is occupied the angle in between. The first quadrant is nothing but the theta is equal to it is on the x-axis in the 0, and again on the y-axis that is bounded on the region is clearly pi by 2. Therefore, the limits are it is r is equal to clearly in this r is equal to 4 and theta is equal to pi by 4. Here we need to observe that r is equal to 2 is a lower part and r is equal to 4 is a upper portion, and again the theta angle between the lower limit is 0, the upper limit is theta is equal to pi by 4 is the value. And after that formation finding the limits, and now we are able to do that easily, first with respect to r limits and after that with respect to theta, like based upon the previous problems. And here integration r means the sine theta is a constant, and again r square r cube is integration is r power 4 by 4. The limits are upper limit is 4 and lower limit is 2. And after that replace and simplification, again we need to further integration with respect to theta, and after finding the total simplification, the solution we need to find out. And again similarly, for example, evaluate double integration r into sine theta dr d theta, and here also the coordinates r is equal to into 1 plus cos theta and above the initial line only. And again here also we need to observe the problem is not given that any directly limits. Here given the equation format, we need to sketch the diagram and find the region and find the limits for r and find the limits for theta where it is bounded the angles. And after finding all these things according to given the procedure, we need to find the solutions. That means first we need to draw the diagram with the help of r is equal to into 1 plus cos theta. And here already we discuss the diagram should be that is related, that is r is equal to into that is 1 plus cos theta. This is the not at all in the circle equation. This is the meaning of that is a coordinate. And coordinate is nothing but we need to observe what is either it may be minus or plus. Minus is nothing but it is the left side and plus is nothing but it is a right side. And therefore, based upon this one, while we are going to draw the diagram, it should be clearly it is a coordinate is parallel to like a x-axis. It is clearly. If it is 1 minus cos theta, that reverse of the left side that is a coordinate. But here 1 plus cos theta. And in this also, while we are going to observing, the total bounded region is actually it is a coordinate is nothing but according to all this total shape. Bounded region actually. But in this, our problem is given consider only above the initial line. And under the above in the initial line means it should be only covered the above part. The above part including. That means here it is not covered the below the part of the conditions. That means we need to draw the diagram first one, and after that we need to consider what is a given problem, then that is a problem. And here while we are going to take this one, here it is clearly that is a totally the coordinate, it is considerably above the axis. And here we need to identify what is the region, the lower part, what is the region, outer part, and what is the like angle in between the lower angle and again the upper angle. While we are going to observing here, the region is starting from origin, and again the outer part is totally that on the coordinate. That means that lower part is r is equal to 0 and upper part is into 1 plus cos theta and theta. The theta angle is the lower part to outer part in between the angle. The lower part is nothing but it is the theta is equal to 0. That means it is theta is equal to 0 and pi. What it is the pi? That is according to here 0 and pi by 2 and it is a pi. That means from here to the angle is in between the lower to outer part it is a covered. Therefore, the limits are theta is equal to 0 to pi. And after finding these are the limits, again, as we know that how to find the integration with respect to r comma theta. And here, first r integration is r square by 2. And again, after that replacement of upper and lower. And again, we need to integrate with respect to theta. Then find the limits, replace the theta, that is 0 to pi. Therefore, after that simplification here, we obtain the solution. Here r is equal to that is 0 and r is equal to upper, and again the theta, that is a lower part, and again it is a pi, that is a condition is like that. That is according to whatever it may be, we need to consider. Find the solution. For example, like this. It is also same related to the previous one, but it is also called as a coordinate. And again, but it is a 1 minus cos theta. That means the opposite side of the previous problem, that is a coordinate is a left side. Therefore, here also there is no change. Almost it is also problem. The diagram should be, it is also based upon the condition. We obtain the problem is like this. Same, there is no change. The theta is angle between the 0 to pi. And again here also condition, limits, we need to find the solutions. Yeah, here also like r is equal to a into cos theta, and this is also nothing but one type of the circle, as we are given that r is equal to a into cos theta like that, and it is also cos theta is nothing but above the circle, like above on the x-axis. We need to draw the diagram of the circle, that is the conditions. That is with the help of the conditions. Yeah. Yeah, like that, any number of problems are given, we need to sketch the diagram, and again based upon like any problems are given, like based upon like other examples, like any number of problems. Like this, any number of problems are given, like under the double integration, and also whenever the limits are like under the polar coordinates r comma theta, we need to follow according to these are the instructions. That means whenever the first is r, we need to find out that r, and again after the theta in between in terms of the pi. And again if some problems are like according to here, the problems are given like not given any limits are like polar coordinates r comma theta, they are given such type of these are the equations. First we need to understand, and according to that circle or coordinate or something lemniscate or something any related, and based upon the equations you need to draw the diagram. R values you need to take that region from inner to outer, and theta is equal to the lower angle between to the outer angle, and after finding all the limits we need to find the solution. These are the clear information regarding the under the double integration. Whenever the limits are like a polar coordinates like r comma theta, we find the solutions. And further we need to discuss in the next class, that is based upon the change the order of integration and certain related the problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.